Friends, and welcome for another session. We have started with plastic analysis of portal frames. So today we shall solve one more variety for portal frame. So let us start. This is a frame with same column heights on both the ends, but support conditions are different. Right hand side column, bottom end is fixed, and here on left hand side it is hinged. Then left column and this beam both are subjected to uniformly distributed load. Let us say this is 20 kilonewton per meter and this is 25 kilonewton per meter. Okay, ABCD. 4 meter is the span of the beam and 4 meter is height of the frame, both columns. Okay, so a little bit complicated. Now procedure will be same. What is the difference between previous frame analysis and this frame analysis? There is uniformly distributed load on column. So this frame is going to sway obviously because end conditions of columns are different. Unbalanced horizontal force on the frame, so it is a sway type of portal frame. So there will be sway mechanism. Now there will be two beam mechanisms. One is in the beam, another is in the column, because column is also subjected to this load. In previous case horizontal load was there, yes, but it was on the joint. Okay, so it did not create any beam mechanism in column. Okay, so here there are two beam mechanisms. So let us start with these two beam mechanisms. Our first step, beam mechanism. So we'll start with beam first, which is simple now. B and C are intermediate joints, so they will be assumed fixed ends. And here is the UDL, 25 kilonewton per meter. End conditions are same and load is symmetric. So plastic hinge is going to form at the center of the beam and on fixed ends, correct? So these are three locations of plastic hinge. So this is simple, theta on each side, rotation. Here is MP because this is fixed end. This is MP, MP, and one more MP value. Okay, so this delta is how much? This is 4, so this is half of 4, 2. So delta is 2 theta. Okay, delta is 2 theta. Internal work done. Internal work done is 4 MP theta. Simple. 1, 2, 3, 4. 4 times MP theta. What is external work done? Let us do it. External work done is 25 into this area of triangle. So 25 load intensity into half. I'll write now directly value of delta. Okay, so 25 into half into base is 4. Okay, this is 4 into height is delta. How much is delta? 2 theta. So this is here 2 theta. So these two gets cancelled. So 25 into 4, 100 theta. Correct? 100 theta. So external work done is equal to internal work done. So 4 mp theta is equal to 100 theta. So this is simple. mp is 100 upon 4, which is 25 kilonewton meter. So from beam mechanism of beam BC, we have got mp as 25 kilonewton meter. Now we will go for beam mechanism of column. Correct? So it is here. Again, this is hinge support. This is fixed because this is internal, and there is UDL. How much is UDL? 20. Correct? 20 kilonewton per meter. So now what will be there? This is a case of propped cantilever subjected to UDL, only that it is vertical. Correct? So this is fixed end, this is hinge end, UDL. So where is the plastic hinge formed? At 0.414 times L from end A. Correct? So let us draw its deformed shape first. It is here. 0.414 L. Let us say it is here. So I will show here 0.414 times L, and how much is this? This is 0.586. I hope this is correct. 0.586. Please remember that standard result. Okay. So how much is this value? 0.414 times 4. Let us calculate. It is 1.656 meter. Okay. And how much is this value? 0.586 times 4. 2.344. 2.344 meter. Okay. So beam mechanism now for column AB. This is, we shall say, delta 1. We'll use separate or different symbol for delta values so that we need not get confused. So we have to now show plastic hinge locations. This is end support, hinge, so there is no plastic hinge here. Correct? Then this is location of plastic hinge, and this is fixed support, which is internal. So another plastic hinge. Okay, so this is, we shall say, theta 2. This is theta 1. So from geometry, this is theta 1. This is theta 2. So we have shown now mp theta values at appropriate locations. Now we want internal work done first. What is internal work done? mp theta here is one time, here is second time, here is third time. So mp theta 1 plus 2 times mp theta 2. So we need first of all relationship between theta 2, theta 1, delta 1 and so on. So from this, delta 1 is equal to 1.656 theta 1. Another value of delta 1 from this right angled triangle is 2.344 theta 2. Equate these two. So 2.344 theta 2 is equal to 1.656 theta 1. So how much is theta 2? Let us see. 1.656 upon 2.344. So it is 0.706. Correct? Theta 1. So let us substitute MP theta 1 as it is, we will keep, plus 2 times MP into what is theta 2? 0.706 theta 1. So make total 1 plus 2 times 0.706 is 2.412. 2.412 MP theta 1. Okay. Now external work done. External work done is again load intensity into area. So 20 is load intensity, correct, multiplied by half base is 4 into delta 1. What is delta 1? 1.656 theta 1. I'll write directly 1.656 theta 1. So how much is this value? So 20 by 2 is 10. So 10 into 4 into 1.656. 66.24. 66.24 theta 1. So equate these two. 2.412 MP theta 1 is equal to 66.24 theta 1. So how much is MP from this? 66.24 upon 2.412. So it is 27.46 kilonewton meter. I'll write here another value, 27.46. Okay. Now I will rub this. We need to remember external work done values. From this 100 theta, from this 66.24 theta 1. Okay. So now we will rub this. Okay, so sway mechanism. So now this is deformed shape of the frame. This we shall say delta 2. This is theta, 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 and this is theta. Okay. So this is hinge support. So there is no MP. Here is MP. Here is MP. And here is another MP. Okay. Delta 2 is 4 theta. This is height 4. So delta 2 is 4 theta. nothing else. So let us now start with internal work done. So internal work done is MP theta. This is MP theta, and here is one more MP theta. So this is 3 MP theta. Now external work done. What is external work done? This load. External work done is this area into load intensity. Okay, because we are not going to consider load on the beam because this load is not causing any type of sway. Okay, horizontal load is causing the sway. So this load intensity into area of this triangle. So how much is load intensity? 20 into area of triangle, half, base is 4 into delta 2. Delta 2 is 4 theta. So this is again how much? 160 theta, correct? External work done is 160 theta. Again equate 3 MP theta, which is internal work done, is equal to 160 theta. So from this we are going to get MP as 160 upon 3. So how much is 160 upon 3? 53.33 kilonewton meter. I will again write this value here, 53.33. Okay. So this was sway mechanism. Now we will go for combined mechanism. What is combined mechanism? Combine the first two parts, beam and sway. So this is our frame. I think draw that diagram here so that we will have space. So this is for sway. I will just add beam mechanism here. Okay, I'll use different color. Here. So this is delta 2. This is delta. And here is this. Now we are not going to consider in sway, in combined mechanism, correct? So this is theta, this is theta. So there is no MP here, there is MP here. And here is MP, this is MP, here is MP. So how many MP theta values we have? So 5 MP theta values. This we are not going to consider. Okay. So let us now get the internal work done first. 1, 2, 3, 4, 5. 5 MP theta. Okay. Then external work done. What is external work? External work done is load into this area So how much is load? 20 into area of this triangle is half base 4 into another side is delta 2. Delta 2 is 4 theta. So this value itself, which is 160 theta, plus UDL on the beam. How much is UDL on the beam? 25 into again area of this triangle. So half into 4 into delta. Delta is how much? 2 theta. So how much is total? 160 theta is first, plus second is 100 theta. So total is 260 theta. Correct? So again equate these two. 5 MP theta is equal to 260 theta. So MP is 260 upon 5. How much? 260 upon 5. 52. Correct? 260 upon 5 is 52 kilonewton meter. So we have three values of MP. This one is four values actually. First one was 25. I'll write one by one here. Correct? 25 kilonewton meter. Second is 27.46 kilonewton meter. Third is 53.33 kilonewton meter. And last one is 52. So which is correct answer? 53.33. Correct? 53.33 is the answer. This is a complicated problem, and for doing the plastic analysis of such frames we need a very good practice. So I request you to solve quite a few number of problems so that you will get an idea exactly how that approach is. In all of the frames or in all the numericals, the approach will be same. There is nothing different, only that we will have different combinations or some complexities like this one. Okay, so I again request you to do a very good practice of solving these problems using plastic analysis. Okay, I hope you have liked this video. If you are new to this channel, subscribe the channel, and if you have any queries, do comment in the channel.